So next up is Shane Kerr from IBM, and his talk is Kobayashi Maru packet sizes.
Hello, thank you everyone. So I probably don't need to explain the title because you're all fans of the original Star Trek. Yeah? So if you don't know, this is a test for Starfleet captains, and the idea is to test their psychology in an unwinnable situation, and so that's where we're at. All right. So how did this start? IBM NS1 Connect is an authoritative DNS hosting platform. That's what we do. And we had a customer that started getting a lot of increased query counts for counts at their zone apex. And what happened was they had grown that TXT record, so it got to the point where it started truncating, which it shouldn't be a problem, right? So what did we see? For most resolvers, everything was fine, but we found a few open resolvers that were having some issues. Now, to be clear, we're seeing a lot of increased data, so we need to figure out where this is coming from. And so I implemented this not too long ago, and like a few years ago, and I thought, well, obviously I screwed it up somehow, right? Obviously I didn't understand the subtleties of how to create a truncated packet and things like that. And what we just do is, if we discover that we're going to go over our packet size, we send a response, which is just the question, and we just say, hey, here's the response, it's truncated, and there's no additional data. Now, I thought maybe this isn't the right answer, so I dug into the scrolls, all the RFCs and everything, and there's a bunch of text in there about when you can use a truncated answer and things like that. But then I remembered RRL does the exact same thing that I do, and it didn't cause the internet to fall over. So probably my technique is okay. So that's probably not what it is. So we looked at it some more. And it turns out that for these particular resolvers that were having problems, we weren't getting TCP. And so the normal pattern you'd see is you get a question, you send an answer that's too big, so you send it with a truncated flag and the TC bit, and then the next thing you would normally see is a TCP session created by that resolver, and then they repeat the same thing. So that is what we were seeing. We're just getting lots of UDP traffic. So the temporary solution for the customer was to reduce the size of the TXT record, which they did, and then of course all the resolvers started working. So our hypothesis, and I think this is correct, is that there are some resolvers with broken TCP that will just keep retrying on UDP until they get an answer. So this leads us to our dilemma. And what we had in the DNS is we've had two DNS flag days, one of which was to reduce to set a sort of hard limit on EDNS 0 packet sizes. So used to be 512 bytes was the limit in the DNS. Nowadays, it's 1232. This prevents fragmentation because it fits under Ethernet frame sizes and things like that. And it gives probably the best chance for UDP to work, if it's ever going to work. And it works around broken networks and networks that don't support fragmentation. Now, the reason that this is a problem is that there are some networks that have working fragmentation support, but they don't have working TCP, because almost certainly of firewall misconfigurations or something like that. And so when we reduced it, and if we truncate in this way, we cause problems for those resolvers that didn't have problems before. Now, you can argue that TCP has been mandatory in the DNS since the beginning, and it was made very explicit, I don't know, 10, 15 years ago, something like that. But anyway, that's the situation we're at. Now, as IBM, we don't care too much about people with badly broken resolvers in specific cases. But we do care about extra queries, and our customers especially care about it because that's how we charge them. All right, so can we fix it? Now, we can possibly adjust the buffer sizes beyond the 1232, get a few hundred extra bytes, and there's been research to show that that's okay. Now, we don't actually track per resolver behavior, and I know some operators don't have this as a problem because for other reasons they do track resolver behavior. So in our case, it would be tricky. We just don't have the instrumentation and the code in place to do that. So one idea that I had when I was visited by the Bad Idea Fairy was to sometimes respect the size and to other times use this limit. It would mean extra retries, but probabilistically they would get an answer pretty quick. And one of our other networking people said maybe we could do both of them. I haven't really thought that through. That might work too. But the whole point of DNS Flag Day was to remove a bunch of workarounds and crap. So our solution in the end was to just not charge the customer for these queries, and that seems to make everyone happy. The load wasn't causing us problems. So here we get to the reason that I'm actually here, which is at least one managed DNS hoster. They implemented these recommendations, and then they saw a bunch more TCP, and they quietly rolled it back and didn't tell anyone. So I guess the question is, do these values make sense? Is there anything that we can do? What kind of things do other people see in their networks? Is this just a problem that affects us because of our situation? Anyway, that's it. I'm hoping to get lots of people rushing to the microphone to explain why we're doing it wrong.
Jeff Houston, APNIC, you actually touched upon a subject that we investigated at some length about a year ago. And the first one is, if you set the truncation bit and give an answer, will anyone look at the answer? In other words, will they just not go in TCP and act like they had it? We did 394 million sample points, so it's quite a few. 96,000 of them just sort of went, it's an answer, I'll take it.
So how many million?
96,000 out of 394 million. So it's
Okay.
pretty small. Canada, Nigeria, Mongolia, Ponderosa Internet in the US, a few folk are doing this. Okay, so what about the TCP thing? So that error is small, and the rest will try and go to TCP. What's the TCP success rate? Oh, so again, the same sample point, 394 million, got truncated. The failure rate was actually 2.67%. In other words, there's a sizable amount of folk, including 91% of the clients of Telmex services in Chile, Togo, Puerto Rico. There's a whole bunch of folk who don't do TCP. Globally, it's kind of bigger than any other problem. So truncating and thinking that TCP is going to work invites you into this other piece of hell that says 97% of the world are following, but 3%, 2.67, are not with you. What do they do then? Serve stale, nothing will help. So it's a problem.
I didn't put it in this presentation, but there's a separate RFC which came out recently from the IETF, which says that additional data, or glue is additional, and you have to truncate if it doesn't fit, which we haven't implemented yet, which will actually exacerbate this problem a little bit more. So,
Don't gratuitously truncate, because only 0.05% of users actually use the data even if the truncation bit is set. But as soon as you set the truncation bit, 3% of users aren't following.
All right, thank you.
Ross Gibson, Infoblox. One of the things that you brought up was firewall misconfiguration, which definitely is going to be a problem because I see it consistently through customers. But I've also seen that some firewalls actually will drop packets that are larger than 512. They're old, mostly, but it's just something I want to point out that it may not be a misconfiguration by the customer. It may actually be the underlying firewall software that's doing it.
Yeah, that could be. And oh wow, 512. Okay.
Yeah. It's more on the older side, but I've seen things like DNS doctoring and other things like that will do it, and not as long ago as it should have been, at least.
Okay.
Thanks.
Hey Shane, Dwayne Muscles from VeriSign. So a year ago here, Ralph and I gave a joint presentation with some data from when VeriSign did the algorithm rollover for ComNet and whatnot, and we saw this same behavior. We saw some very aggressive retries from clients that obviously could not get to us via TCP. I think it was, those aggressive retries were from a pretty small population. It only takes one or two really aggressive clients to sort of spike your stats, right?
Exactly.
But we did see that. In our case, it was from delegations, obviously not like text records. But I'm a little bit, I don't know, I'm a little bit unsympathetic to continuing to try to work around clients that are broken with respect to TCP in this day and age. I mean, you know, that advice has been out there for so long, so it sucks that we have to keep trying to accommodate them, in my opinion.
Yeah, I'm also, I basically agree with your suggestion that if TCP is broken, that's really a problem for the people that have broken TCP.
Yeah, it stinks that you get all these extra queries, right? Then you have to deal with them as a billing issue or whatever. But also, you know, in my experience, when we can do outreach to people, when you can get in contact with someone who is a source of the problems, a lot of times, you know, you can get them to recognize it and fix it. So.
Yeah, I think in the usual case, it's people that aren't running their networks very well, so the chance of getting in touch with them and then explaining to it and having them fix it is pretty low.
I think in the case that Ralph and I worked on, it was an IP tables filter was a limit was being hit, and once they resolved that, then everything was fine. So.
Okay. Yeah, makes sense.
Petr Špaček, ISC. I think that we as an industry have a problem that we are in the race to the bottom, provide the service at the lowest cost and don't cause any breakage ever. And that means that we are piling workarounds on top of each other, and that obviously causes problems down the road. So, of course, we at ISC, when we support bind deployments, we see that kind of problem as well. But I think that the best course of action for us, like collectively as an industry, would be to say, okay, enough is enough. It needs to be fixed on the client side. Otherwise, we will be 20 years later here again discussing the same problem. And with the post-quantum and you name it, the records are not going to be any smaller, period.
We're at the end of time, so please make the last 2 comments or questions quick.
So I didn't mention it in this presentation, but there is also some work, I believe Shimon's doing it, to move text records for domain verification out of the apex, which will make our source of pain in this particular problem a little bit less. So, yeah.
To be quick, this is Puneet from Google Public DNS. Just a contrasting data point from what Jeff Houston talked about with problems with TCP. I can share from experience that before the UDP fragmentation flag day, we were literally getting customer complaints and resolution issues on the resolver side because of UDP fragmentation. So I think when we talk about the problem, we also have to see the problem which was happening when this change hadn't been made. And in our experience, that was a way bigger fraction than inability of TCP to get through.
That's a very useful data point, I think. Thank you.
Ben Schwartz. If only 0.05% of resolvers actually try to use the contents of truncated packets, then we should put nothing in there and instead put some kind of fun message to the resolver operator.
That message to the resolver operator is interesting. Yeah, maybe we'll do that. Thank you, everyone.
Thank you very much.